Good morning, everyone, and welcome to this webinar on Washington and Oregon State Energy Code envelope requirements. In particular, we're talking today about UA trade-offs in the Energy Code. Now, we're going to focus on Washington and Oregon today because they have some custom tools designed to help you do this. A lot of the logic, the math, and the concepts we're talking about are also probably applicable in Idaho and Montana, as those states do use the International Energy Code. So talk to your local people in Idaho or Montana if you're curious about how to do UA trade-offs in those states, if they have a specific tool they recommend. But we're really going to focus today on Oregon and Washington. A couple of quick notes. We are recording today's session, so we're going to keep everyone muted, and we're going to ask that you primarily ask questions through the questions tab or the chat tab. The questions tab is a little bit better for us. And the main reason why is we can track better all the questions that have been asked, which ones have been answered, and which ones might need some direct follow-up. Next, I want to mention that we're hoping that we have some HERS raters and energy program verifiers on the call today, as well as it looks like we might have a couple of builders, some insulators, perhaps even a code official or two, and definitely some other stakeholders from around the region. I bring this up because home energy raters are going to be critical components for any of you who are working in the marketplace who might need some help doing UA calculations. They're there to help you. They're familiar with this type of analysis, and they can probably help you apply this type of logic and this type of thinking to beyond just energy code. So think about that as we move forward. With that, I also did have a secondary title for this, do you even UA? And if that doesn't resonate with you yet, it will by the time we are done with today. We do have a fair amount to cover, so I'm going to go at a pretty good clip, but I have lots of places where I'm going to pause, and my friend Diego is monitoring the chat and the questions, and when I pause between topics, I will check with Diego pretty regularly. So again, feel free to ask questions or put into the chat if you have anything you'd like clarification on, or you can always follow up with us afterwards, and we'll be sure to make sure you get your questions answered. Finally, yes, in advance, we will be sending a PDF out to all who registered for today's webinar. So with that, let's jump in. Briefly, this is our agenda, and it may not go exactly in this order, but we want to talk about, what are the challenges here when we talk about envelopes in the Energy Code. So in Washington and Oregon, they're a little unique. They both have base codes with prescriptive components, but they also have credits or additional measures. And by the way, the IECC is starting to catch up with this. The 2018 IECC actually now has an extra credits table for the first time. The 2021 version, which is under develop, or the 2021 rather does. The next version, 2024, may have an expanded version of this. So the type of thing we're talking about today most directly applies to Washington and Oregon, but it also is going to apply again to other IECC types of states. So those are some of the challenges, right? We've got prescriptive stuff and we've got these additional measures. They usually are asking you to go even beyond the prescriptive elements, potentially in the envelope. Good news is both states have lots of options for how you can get there, but in Washington in particular, where you need to get a fair amount of additional points, it's highly unlikely you're going to do it without doing something for your envelope. So what are the solutions? Well, there's UA trade-offs, and we can do that with some calculators and tools, and we're going to talk about that today. What we're not really going to talk about much today is energy modeling as an option. But we just found out earlier this week that we do know of some jurisdictions in Washington state that are doing energy modeling as an option for energy code. So if you're in one of those areas, that's another way you can address some of these same challenges. We're going to talk in particular about parallel path analysis. And doesn't that sound fun? I mean, what better way to start your Wednesday morning than talking about parallel path analysis using the ASHRAE calculations from the Handbook of Fundamentals. I'll get to that in just a second, why that's important. And then we'll actually go through the tools. The minutes that are on there, those are just some guides. We'll see how much time we actually have to go through all of this. Now, before we go too far down the rabbit hole, just in case any of these words, phrases, acronyms are a little unknown to you, or you think I'm mostly there, but I'd like a little refresher real briefly. We talk a lot about U factors and R values. And in some ways, they are very, very similar. I mean, they're incredibly related. They're the inverse of each other. U factors are a measurement of heat transfer, whereas R values are a measurement of heat resistance. So U factors are typically used when you look at an assembly that is complex or has a bunch of different components. So windows or walls over a large area are a great example of when we want to use a U factor. And the reason why is, let's take a window, for instance. The middle of the window is very different than the edge of a window. And in order to get an overall picture of the measurement of heat transfer through a window, we need to take into account all those different components. The same goes for walls when you start especially getting to a large enough area where you're incorporating doors, windows, heavy framing, all of that, we're talking about U values. R values, on the other hand, they usually describe an individual material or stacked materials where the R's can just be added. So if you're just thinking about a wall and you just want to say, I'm kind of curious about what the R value is with drywall, R21 insulation, OSB, a weather resistive barrier, and my siding, that you can stack those, and that is an R value. But that is just for that portion of the wall. Turns out U values are what we need when we're going to talk about a UA. Now, I'll get to that definition in just a minute. Now, I made a little bit of a jest earlier about how exciting parallel path analysis is. Just again, for a quick refresher, series heat flow is where it's really helpful to use R values because they just stack, where no matter where the heat starts, it flows through each material the same. So you can just add those R values. Parallel heat flow, we use parallel pathways, look at them and do parallel path analysis. And in this case, we average the U values for this. And this can work for any number of pathways. In walls, which we're going to talk about a lot today, you could think about this as what we call the cavity portion, where the insulation, the R21 bad or the blown-in insulation is, the framing studs themselves, and then interesting places like headers and corners, where you may have a combination of both framing and insulation. I've put a little YouTube video clip here that's from Energy Vanguard, a little training that they do on this. You can click on this. I clearly stole these two images directly from their YouTube training. It's okay. I know Allison Bales a little bit. I'm sure he'd be okay with me using this. So that was U versus R and series versus parallel. Now let's talk just a minute about UA and why this is a code metric. So we can talk overall with the building about the Q, or the heat transfer through a surface. In order to do that, we need to know the U value, or the average U. We need to know the area, and then we need to know the delta T, or the temperature difference. When you think about this, unlike with energy modeling, UA is a non-climate specific metric for average heat transmission of an area of the exterior of a building. So this means it can be used in any climate zone as a way to evaluate potential thermal envelope performance. With energy modeling, the heat transfer is calculated with climate-specific temperature differences. So it's a much more nuanced and incredibly more powerful way to look at buildings is to do full energy modeling. What is easier to apply equitably across large regions with pretty diverse climate zones is just looking at the UA component only. You may have heard me mention ASHRAE before, earlier on. What is ASHRAE? Who are they, and why are they all up in my business? So ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And they generate what they call the Handbook Fundamentals, or what is commonly referred to as ASHRAE's Handbook of Fundamentals. And this covers all the basic principles and data used in the heating, ventilation, and air conditioning and refrigerant industry for residential buildings. So the Handbook of Fundamentals, you can think of that as, this is the Bible for doing the math, right? How does heat move through these different types of things? You're also going to see and hear references to ASHRAE 90.1. Now this is actually a benchmarking kind of platform, and it's set to really look at the minimum energy performance standards and energy codes. And it really is there to provide the minimum requirements for energy efficient design of most buildings. Now 90.1 is most commonly used in multifamily and commercial settings, but it's sometimes referenced because embedded into the calculations for ASHRAE 90.1 is the math from the ASHRAE Handbook of Fundamentals. So this is what we want to reference on a pretty regular basis. The IECC and most states with their own codes will say if you are going to do heat loss calculations, you have to use the ASHRAE math found in the Handbook of Fundamentals or in 90.1. So we're going to jump into the Washington and Oregon codes and UA trade-offs, but I want to pause real quick because that was pretty fast. Just see, Diego, any questions or comments come in so far to address?
Thanks for checking in, Dan. You're doing a great job so far. I think folks are just really taking in all that information. So no questions at this time.
Perfect. I see we do got a great group of people attending today. And for those of you watching this recorded, yes, you'll be able to ask us questions at a later date. So let's jump in a little bit more here. So let's talk about that base code in Washington. Remember I said earlier, the challenges are we've got our base prescriptive code elements, and then we also have our additional measures. So for starters, this is an example of table 402.1.3 from the 2018 Washington State Energy Code. And don't let that confuse you. 2018 is the current one, even though we are in 2022. This just happens to mean that was the base code that was used to develop it. So within this version of the table, there's another version which has R values instead of U factors. Again, since we're going to talk UA today, I chose to use the U factor version of the table. And what you're going to see here is if you look at R402.1.3, you can do a U factor alternative approach. So an assembly with a U factor equal to or less than what is put in the table is permitted as an alternative to the R value in the other table. So U factors shall be determined as specified in a later chapter. So let's look at what that actually looks like. Here's part of this later chapter. If you're going to do U factor, there are some references and calculations that you're going to need to find. And look right smack dab in the middle of there is you need to do things in accordance with ASHRAE's Handbook of Fundamentals. So this means that there are going to be the heat loss math that's going to be very important. And here they also call out specifically the framing factors that are found in Appendix A of the Washington State Energy Code. Framing factors, that is a overall percentage of a wall that has the insulation cavity, the percentage that has studs, and the percentage that has headers. It is very specific and different for standard framing, intermediate framing, and advanced framing of wood framed walls. It's an entirely different animal if you're talking about things like Larson truss systems or metal framed walls. We're going to stick to dimensional lumber today for the majority of this conversation because that is by and large the most common way that we see things being done in the Northwest. So again, ASHRAE Handbook of Fundamentals is being called out specifically if you're going to do an alternative approach to a UA or U factor calculation. So overall, UA trade-offs are allowed as part of the base code in Washington, provided you use the ASHRAE Handbook of Fundamentals and that Appendix A. And don't worry, I'll show you Appendix A right now. Appendix A has several components in it, and it covers a lot. It covers walls, it covers ceilings, it covers wood framed buildings, it covers metal framed buildings. But it does a couple of things that are really critical. It tells you your default heat loss coefficients. So what is the R value of an interior horizontal surface with the heat flow going up, or an interior horizontal surface with the heat flow going down? So these are fixed values that you're required to use as part of your calculation. Don't worry, we're not going to make you actually search through all, oh gosh, it's hundreds of pages long if you actually go through the full handbook, all 4 sections of the Handbook of Fundamentals or the 90.1 user guide. Those are enormous books. We're not going to make you look through them all. We're going to show you the tools that you can use that are ASHRAE compliant. So this is default heat loss coefficients. This Appendix A also provides some of these framing weighting factors. You'll sometimes hear these referred to as framing fractions as well. So when you look at this example here for intermediate framing right in the middle, on the right-hand side, it has studs and plates are 18% of an average intermediate framed wall, and insulated cavity is 78%, and headers make up about 4%. If you look down to advanced framing, you can see that the studs and plates make up a considerably smaller amount of the wall. You just think about that for a second. If I'm putting R23 insulation in my wall and I have a 2x6 stud with a R value of about 6.8, that's a pretty big difference. I would love to have less of that R6.8 and a lot more of that R23, right? So talking about going more advanced with your framing is one of the ways to improve your overall UA. Let's take a quick look at Oregon. So the base code in Oregon has a standard base case, and here they chose to put the U and the R in the same table, as opposed to Washington, which puts them in separate tables. We're not going to focus on log homes today, but they do have that because we actually do build log homes here. And you see this little A up at the top I've just circled, right? Hopefully you can see that. Aha, footnote time. So what does our footnote have to say about prescriptive envelope requirements? Thermal performance of a component may be adjusted provided that the overall heat loss does not exceed the total resulting from conformance to the required U factor standards. What does that mean? You can do an alternative UA provided that you meet or exceed the U factor for the prescriptive table. They go into a little bit more here with a section called alternative systems. And here what they say, for calculations under this section, the following parameters apply. You have to use the 99% winter design temps, and you have to use values listed in the ASHRAE Handbook of Fundamentals. So again, this is going to be a pretty common theme. UA trade-offs are allowed for the base code. You need to use ASHRAE 90.1 or Handbook Fundamentals for compliance. Now, Oregon does something a little different than Washington does, and some other states I've seen do this as well. They actually have a table that you can print out and fill in with your proposed alternative UAs. So this is something you could actually submit as a part of your code permitting process. So if you wanted to do something, let's say you want to have a wall that's better and a floor that's worse than is prescriptively designed, or maybe you don't want to go with 0.27 windows, you want to go with 0.29 windows. How much better would your ceiling or wall need to be to get that same proposed UA to be the same or less than the code UA? So it's a pretty handy table. Washington State does it differently, and we're going to show you in a few minutes. They're a really cool tool they have called the Code Compliance Calculator. So, boy, that is already a lot to go through, but we're already a quarter of the way through our presentation. So it seems like another good place to stop and see any questions so far about what the base codes, how they're designed, and what they're allowing in terms of UA trade-offs. Diego, anything new?
Thanks again for checking in. I think you're still just giving us a lot of really relevant information that just deserves some attention and some absorbing from the crowd. So no questions at this time.
Great. So we started with the base code, and you'll remember that I said the next set of challenges are these additional measures that these codes bring up. So Washington State has this table called 406.3. This is their energy credits, as it's often referred to. Sometimes it's called the energy points table. And within the efficient building envelope option, or option 1, there are several options that allow for UA trade-offs as a way to comply. So option 1.3 gives you a prescriptive way to meet it. You could do windows at U of 0.28 and a floor of R38. Or you could use compliance, as we described earlier, and reduce the total UA by 5%. The same is true with 1.4, 1.5, and 1.6. They're increasingly more stringent, but they give you more points or more credits. And in Washington State, on average, you need 6 credits to comply with the energy code. So it's virtually impossible to achieve that without doing something, getting at least a half or a credit in this section. So the examples we're going to look at for Washington State, we're really going to focus on option 1.4 at that 15% reduction, because it's pretty common to shoot for 1 point in this section of the Washington State table 406.3. You can do the same math, you can do these same trade-offs for higher values at 1.5 and 1.6, where you can get 2 or 3 credits, but that's a lot more challenging. Let's start with our examples for pathway 1.4 or option 1.4. How about Oregon? So Oregon has what they call their additional measures table, N1101.1 parentheses 2. And there are actually several places in here where you could do trade-offs pretty easily. The ones we're really going to focus on would be measure 3 and measure 6. So measure 3, let me highlight that. is for wall insulation specifically. And what they're looking for is prescriptively, you could do R21 with R5 continuous insulation, or a U value of 0.045 or better. So you could use a trade-off calculator if it's approved and you're using the ASHRAE math to show just that wall insulation upgrade. Alternatively, you could look at the overall high efficiency envelope for Oregon and get your additional measure by getting your proposed UA to be 8% lower than the code UA. Now, again, don't worry, you don't have to do all that math yourself to do the calculation and compare the two and see, am I at 92% or less? We've got a calculator we're going to show you in a minute that will do all of that for you. So we've now covered the prescriptive components, and we've covered the additional measures for Oregon and Washington. Seems like a good place to pause again and just check to see if any questions have come.
Definitely a great place to pause, Dan, as we got a first great question in here. This is specific about one particular calculator this asker is using. So this person asked that they are using the 2021 ORSC additional measure number 6 calculator. And they were curious if this is an effective tool to use in order to show a percent above the base UA code.
That is a great question, and in effect, it does do that, and we'll get to that in a minute. But again, it's only applicable to Oregon. So let me be really, really clear with this measure 6 calculator, and we'll actually show you the example of that in a few minutes. Actually, we're going to go through building a custom U-factor assembly first, I think, and then we'll jump into it. This calculator is allowed to be used for 2 things: overall UA trade-off or compliance with measure 3, 4, or 6 from the code. It is not designed or connected to any programs like Earth Advantage, Built Green, or the EPS new construction offering. Those programs you may be able to work with a home certification program, but effectively a utility program is not going to be designed to use this. Those programs instead use the energy modeling approach that I talked about a little earlier.
Thanks for answering that. We had another question come in specific to Oregon as well. This person asked if UA trade-offs are available for measures other than 3 and 6.
Yes, they are. You can use this calculator for the overall UA of a building, and you could also use it for measure 4. Measure 4 is a little bit more complicated than 3 and 6. So we're going to choose to show today the more simplified versions of it. And we're also going to give you the contact information for the folks at the Building Codes Division at the end, and they can answer some specific questions, because despite the guidance that we are sometimes given by whether it's a permitting official or someone who works at a state agency, sometimes the language that's on these calculators can be a little confusing. So we're going to make sure that we actually give you the contact information. So those of you who are really interested in this and you want to dive deeper, you could. In that particular question, I know that one of the reasons that person was asking this is, what about if I went with really cool windows, right? Oregon has an additional measure for 0.21 U value windows. What if I can't get 0.21, but I can get an average U 0.23 window? Well, that could certainly be helpful, right? Well, you could do it as part of measure 4. You could do it part of an overall UA trade-off, which is not an additional measure. That's just basic code compliance. Or you could use that as part of measure 6 as a way to comply. Great question so far. Let's keep going. So what if I have a custom wall or ceiling or floor, right? What if I've got something that I've looked at what is kind of put in the appendices of these codes, and I just don't see a U value, already assigned for that. So the first thing I would say is take a look in the actual code language itself, in their appendices. Sometimes you'll have pretty detailed tables where they will say, please use this R value or this U value for this type of assembly. And then you're going to want to check the 2 tools that we're going to go through and take a look at those tools to say, are these already put into the tools? Did someone already think this through? If not, do you know some basics about this custom wall or ceiling or floor? Like, do you know the framing fractions? What percentage of the wall has wood in it. So you can see here there's the Larson truss being tilted into place. That's a little bit more interesting to do the math on the framing fraction, right? So you're going to want to work with someone who understands this type of wall system, has seen it dozens of times at least, and knows how to calculate those framing fractions. And then you're going to use the ASHRAE math. It's also sometimes referred to as the IECC equations, because the ASHRAE math is put in equation form in most versions of our local codes. So start there. We're now going to walk through some examples of these compliance tools, and then we'll go through some available calculators in the marketplace. And I know that there's more out there than what we're going to show today. I just went through 3 or 4 that were easy to find and easy to reference. So you could build your own custom U factor, overall U and UA, using some of these market-based tools and then put them into these calculators. But let's start with the calculators, because again, the first thing we want to do is say, is it in the code or is it in the compliance tool itself? So let's start looking at these compliance tools. We're going to start in Washington State, and here you've got the WSU Energy Program's website. WSU Energy Program is the one responsible for doing energy code support. They manage the code hotline, and they develop a lot of tools, resources, and training around the energy code for Washington State. I put the link down here at the bottom. That will be a live link when you get this. So you go to this link, you go to their webpage, and you scroll down. So you see my arrow here. We're going to go past the prescriptive worksheets, and we're going to go down to this section that's called the Code Compliance Calculator, or you'll hear us refer to it as the C3 for short as we go through this. First, always, if there's an option to click on the README or something like that, or instructions link, I mean, it sounds like a no-brainer, but this one is a little nuanced, so you definitely want to do that first. Read the README tab. Then you actually will right-click on the Code Compliance Calculator and click on Open in a new tab. This is going to automatically download the C3 workbook to your computer. Now, I want to be very clear, this is an Excel tool for Windows only at the moment. So it doesn't work with Google Sheets, and it doesn't work for Excel on Macintosh yet. That may be a further iteration in development, but for now, it works for Excel, for Windows, and for Office 365. There's some also additional help here, because there's no way we can cover all of this in the amount of time we have today. There's these videos available to really help you get started with this code compliance tool in Washington, because there really is a lot going on. So once you open it, you want to click on the Getting Started tab and read through this. This is just a quick screenshot. There's a lot going on here, but this is going to be your best friend, is really understanding this. You are going to need to do some basic things like save a version to your computer, and enable edits, and then enable the macros in order for this to work. Once you get started, there are going to be 3 critical things that you want to do to make sure this is successful with the C3. The first is you want to make sure that your analysis setup is correct. So each of these is a pull-down list. So we could look at prescriptive path compliance with option number 1. Remember, option number 1 is the envelope upgrade options for the code credits. You want to look at, you can click on new construction or existing. You can click on single family or multifamily. Heck, you could even use this for older codes. So right now, this one has the 2018 Washington State Energy Code. You could also compare this to a 2015. Next, you would go ahead and click on the options for the code credits that you want to do. And this is just an extra helpful thing. It's going to do a couple things. One, it's going to give you your total credits, and this is a compliance possibility to submit this to your code official, so they actually know that you're meeting the code. But by selecting the option number 1, efficient building envelope, option 1.4, this is automatically going to pre-populate in the background what you're comparing your proposed envelope against. And then you go in here and you're going to add your size of your house, your conditioned floor area. I just picked 2,250 square feet, kind of a very average size in Washington and Oregon. And it automatically knows in Washington that that's a medium-sized dwelling. Washington State, there's different credits needed for small, medium, and large. So if you do those 3 things first, you've set yourself up very well for success. So let's take a look at some example trade-offs for 1.4, right? So this again is the equivalent U factors for the base case, and then you've got 1.4 in the upper right-hand corner. In it says U value of windows of 0.25, walls 21 plus R4 continuous, and a floor of R38, or reduce the total conductive UA by 15%. So let's take a look at an option for this. So on the left, let's take a look at this package. We've got the windows, the wall of continuous insulation, and an R38 floor. That to get to 15% or to do 15% reduction. Maybe, however, you're looking at this, you're saying, you know what, we're just having a really hard time, whether it's cost reasons, training reasons, or sourcing materials reasons, we're just not yet ready to move to continuous insulation. So what if we looked at a different package? What if we looked at R23 blown-in insulation, even at 16 on center, we're not even going to advanced frame, but we're willing to do an advanced frame attic. This typically means an energy healed truss with R60 in it, and we didn't change the windows or the floors. Would this get us to where we want to go? So I put all of this in into the code compliance calculator, and you see right up at the top, UA reduction, proposed UA is better than the baseline by 16%. So UA reduction meets the selected option of 1.4. So congratulations, by putting that in, that actually worked very well. Let's take a look at another option really quickly. Maybe in this one, we have, we've got a couple of things going on. Maybe our insulator says, boy, Jeremy, do I have a deal for you. We've got these crazy R20 bats from Germany. They're almost like magic, and I got a really good deal on them. I know that's not standard, but we can get you this, and maybe we can do that with R3 continuous, a ½ inch of insulation. That's a lot easier to get over that hurdle on cost and training with my crews. And if we do something like this, we might be able to back off those 0.25 windows and go with the 0.28 window. We should run this and see if this will qualify. Well, the problem is when we open this code compliance calculator, there isn't an option for an R20 wall plus R3. So I can go down here. If you look at row 920 or index 920, I've created my own entry here of R20 cavity insulation plus R3 continuous insulation. And I had to put in a custom wall U value. And we'll get to that in just a minute of how we actually did that. All right, so I've got a custom wall U value 0.050. So let's take a look at that, and congratulations again. This is 18% better. It does qualify. You will see this red thing up top, right? A review required for custom entries, both vertical glazing and an above grade wall. So now a code official knows, hey, someone's done something custom. What I happened to enter here was a custom sliding glass door as well, plus a custom wall entry. So that may trigger a building code official to say, this is great, I'm really thrilled for you. Let's take a look at how you got your 0.050 for your wall action. By the way, you can also change this view here. Instead of looking at option number 1 preferred, you could instead do a total UA whole building trade-off analysis. And this is good. It has some different assumptions in the background. Maximum baseline window area is 15%, so it basically fixes your baseline window glazing. So if you're want to do a whole building UA trade-off, the less glazing you have, the better it's going to look. Whereas that glazing percentage trade-off would not apply for the envelope only option, but for the envelope 1.3, 1.4, 1.5, 1.6. For doing a whole UA trade-off, though, it would. And I'm looking at this, and vertical glazing exceeds 15%, so you actually get a little alert there, so you know. But this does propose UA is better than baseline by 13%. Well, the good news is that certainly it's better, so it qualifies as a total UA alternative, but probably would not have qualified you for 1.4. So I'm going to pause again and see some questions before we dive into Oregon's tool.
Thanks again for pausing, Dan. A few folks just wanted to clarify on where the links live that you were mentioning a few slides ago, and where exactly to find those. And so am I correct in making sure that we can provide those links in our follow-up email?
Yeah, and I do apologize. Originally We thought we might do this just for Washington or just for Oregon. And that would have allowed us to go a little slower. So I apologize to whoever asked, yes, we are going pretty quickly, but this is going to be available to you and all those links will be live. I may even go ahead and just put the direct links with basic instructions in the body of the email as well. So you don't even have to open the entire PDF to see it all. But absolutely, we will make sure this is all available. And I do apologize for the speed. This is the classic conundrum of we've got a lot to go through and only an hour of your life to command. So we're trying to do the best we can with the time we have. So let's take a quick look. Well, I should ask, was that the only question or is there anything else?
That's right, Dan. That's the only question
Okay.
at this time.
Perfect. So let's take a look at what's going on in Oregon. Again, apologies for how fast we're going. Here is the link. I know if you're trying to write this down or take a picture with your camera, do it quickly. But this is the landing page for the Residential Structures Code program for the Building Codes Division in Oregon. Again, that link will be live. You're going to, once you get here, you're going to scroll down and you want to get to this page, Adopted Codes and Standards. I actually put the link directly to that as well. And you're going to click on Residential Energy Code Training and Compliance Resources. Once you get to this page, and again, sorry for the speed, you'll get to compliance, the Adopted Residential Energy Code in Oregon, and here's the Measure 6 Thermal Performance Calculator. It's kind of ironic that both Washington State and Oregon have these really great calculators. Neither one is called a UA Tradeoff calculator, which would have been really helpful and handy probably, but that's okay. Everyone has their own reasons for the way they develop them. Who am I to judge? But this is the one you want, the Measure 6 Thermal Performance Calculator. So let's take a look at what this tool looks like. Here's a snippet of it on the right. And again, there's going to be an instructions tab. Definitely read the instructions. It's designed initially for Measure 6, but you can also use it for Measure 3 and Total UA Tradeoff. Now, I mentioned briefly earlier on that there is sometimes language that seems confusing. So right here it says for demonstration compliance with additional Measure 6 only. That's actually not true. That's just this little box at the bottom where it says pass or fail. That pass or fail is only applicable to Measure 6. You can still use this for Measure 3. You can still use this for Measure 4. You can still use this for Total UA Tradeoff. You just are going to have to be very clear about what it is you're looking for when you do that. This pass-fail will not give you pass until you are 8% better, which if you were doing a Total UA Tradeoff, you're probably not going to be 8% better. So that is a bit of a conundrum. And I apologize on behalf of the universe that is not more clear, but that's why I wanted to spend at least a couple of minutes bringing this up. This calculator can be used for these other measures. It's just the pass or fail you're not really worried about unless you're doing Measure 6. So again, if you remember, we've got on the left-hand side is this table that you could fill out if you're doing it by hand. And on the right are these additional measures. And again, I wanted to point out Measures 3 and 6 as the examples that we most likely want to use. So when you start with this, the first thing you're going to do, this is the top half of the calculator, and this is going to be the standard base case. And all of these yellow boxes are places where you could enter in data. So it explains that yellow is for entering data. Again, I've got a 2,250 square foot house. I've got about 1,200 square feet of ceiling area, about 1,200 square feet of floor area. And did the math on my walls. I got 2,555 square feet of wall area. On the right, this is a different tab. This is for Windows. There's another one for walls. For Windows, I went ahead and put it in. Now, you don't actually need to enter anything if you're using the code window, but I just wanted to show you this for entry purposes. I could also have some that are at code at 0.27, some that are at 0.30, and some that are at 0.24. And I could have a nice mix there. And once I do this, again, I don't need to do this for the base case because it's assuming the base case is the code. So start by entering this. Now let's take a look at some UA Tradeoff opportunity. remember the prescriptive base case is windows at 0.27, R21 intermediate framed wall, conventionally framed R49 attic, and a floor of R30. What if I wanted to get this measure 8? So I want to see if I can get 8% better. What if I kept the windows as code? I kept my R21 wall, but I'm willing to add a 1/2 inch of continuous insulation, and I'm willing to go to R38 in my floor. Maybe I'm building in both Washington and Oregon, so I'm already doing it in Washington. It's silly to have to do and order different products in the state next door. Would this get me that 8%? So now I can enter here, and I go to each of these pull downs, and I'm selecting the things that I want to do. And it will tell me if I pass or fail. So this is where I'm using the pull downs as one way to do proposed alternatives. And I get this example on the right, and congratulations. This was a 10% better than UA, and it does show that I've passed. But what if the wall I wanted to enter was not R21 with R3.5? What if I had something that I wanted to do that's a little bit more custom? Well, the good news is, here's one, R21 with R3 continuous insulation. That's much more common than R3.5, because this is a 1/2 inch usually of XPS insulation, right? So I can do this and add this custom wall component. So I knew that, R21 plus R3 3.5 continuous passed. Now I'm curious if it would pass with just R3, because a 1/2 inch of foam instead of some specialty thing sounds a lot better to me. Basically a 1/2 inch of XPS instead of a 1/2 inch of polyiso. So I can go in here and enter in my wall area and my custom U factor that I put in. And what does that give me? Guess what? I'm now at 8.5% better, and I've passed. So it wasn't quite as good as the R3.5 continuous, as you would expect, but I was able to show compliance and that I passed. So good news, this calculator is actually pretty easy to use. You could also use this for overall UA trade-off. So let's say I'm looking at windows, and I'm finding it hard to get 0.27 windows at the cost that I want on both sides of the mountains in Oregon. Maybe they're easier to get in Portland and Eugene than they are out in Bend. But I can get 0.29 windows just about anywhere. So maybe I could look at this and say, what if I did 0.29 windows, but I did R23 in my walls? What's that gonna look like? Well, I go in and change my windows to 0.29. And I've got to say, geez, look at that. Even without R3, just with the advanced framing, I actually looked at the base case UA and the proposed UA. The proposed UA is better, so that qualifies for overall UA trade-off. Remember, we don't care about that pass-fail for overall UA. That's only for that measure 6, where we're looking to get 8% better. Now, I know that was a lot, and I know I went fast, so I want to pause and see what kind of questions we have before we get into tools for calculating custom U values.
Thanks for taking a pause, Dan. We did have one specific question that's specific to Washington. They have a scenario that they wanted to run by us here. They have a 500 square feet basement addition added to the whole house alteration. The floors are increased from 2,200 square feet to 2,700 square feet. They wanted to know if C3 will handle this combination calculation.
It's an excellent question. The version that was posted on Monday on the WSU website is not yet capable of this, but I was able to talk to Carolyn Roos, who is the person who oversees this, and she sent me a custom version that is going to be uploaded, we think this week, and it absolutely will be able to do this. It actually gives you an entirely secondary set of inputs that you can put in, and this allows you to handle additions and renovations as well. So you can have different square footages, for instance, between the two, and you can do a lot. You'll be able to do a lot more with the tool very soon. So the initial one was to cover, the base case for most new construction options. They're absolutely able to do additions and renovations and existing buildings, all that kind of great stuff with the new tool that we could even be uploaded as of now. It wasn't yet on Monday, but We think in the next week or so it should be uploaded, and it's pretty terrific. Any other questions? Or you said that was just the one?
That was just the one for now.
Great. Well, let's go through the last little section, and then if we've got time, we'll have some more at the end. I just want to refresh this part again. This is that series heat flow versus parallel heat flow. So this is where creating a custom U value, it's not as easy as just taking 1 over the R for the insulation that I put in, right? Because for a parallel path, I need to know what the heat loss is through the framing, as well as through the cavity, as well as through the headers. So wouldn't it be great if there were some tools out in the marketplace that could help me do this so I don't have to build my own spreadsheet? And spoiler alert, oh gosh, 16, 17 years ago, myself and Andy Gordon, who used to work at Washington State University Energy Program, we created our own custom spreadsheet that did all this stuff for us. I got to give big nod to Andy and the WSU team because they did the first version and I did the second version of it. But boy, we've come a long way. You don't need to do that anymore because there's a bunch of cool tools that are out there. So Applied Building Tech and Building Science Advisor are two pretty cool tools. They are capable of doing some of this. Now, they're not going to be as nuanced as some others. This will allow you to do a parallel path, at least for framing and body of insulation, but maybe not including the headers because they're just not that nuanced. But you'll remember the first question is, are they using ASHRAE, right? Will I get into any kind of trouble if I use these? So the ABTG wall calculator does say it's really hard to read it right there, but it does say aligns with 2016 and 2019 versions of ASHRAE 90.1, as well as 2015 and 2018 IECC. The highlighted portion of the Building Science Advisor does say according to ASHRAE 90.1. So that's some really good news. These are both using the ASHRAE math. So if you were going to use one of these to do a custom UA or a custom U value to put into one of those UA calculators, you're going to want to do screen captures or something. The Building Science Advisor is great because once you enroll, you can save every wall that you put in. So you could PDF them and send them along as part of what you're doing. It's a pretty cool tool. It's free. It also has this other cool thing of moisture durability and performance. So you can put in what climate zone you're in. And it not only tells you how you're doing against code, it tells you how you're doing with moisture and durability. There's another great tool out there called Redcalc's Parallel Path R Value Tool. And here's the link to the tool guide. And this will give you an equivalent total U factor and equivalent UA even. So this kind of is a very helpful tool to be able to use. And good news is this is using ASHRAE as well. So that was something really kind of critical that we want to make sure that these tools are all doing this. Now, some of you are saying, that's great, Dan. I'm already neck deep in this tool called REMRate that I use for energy modeling because I'm a HERS rater and I want to do this kind of work. And I also want to provide tax credits and utility incentives and HERS scores and Energy Star. Can I use REMRate to do this? So here's REMRate, an example of a parallel path calculation that I'm doing. So when you go into your above grade wall type library or ceiling or floor, you can do what's called the quick fill or the parallel path. Parallel path, you can see I've got 3 paths: cavity, framing, and headers. The question is this meeting ASHRAE? Well, kind of. REMRate is a tool that has to meet the requirements set forth by ResNet. And what you've got on the right and what this link is on the bottom here is the link to the ResNet ICC standard 301-2019. And what it actually states here is, so they do a couple of things. They actually have an insulation grading built into their tool, which is actually more conservative. So you can make this wall less and less or less resistant to heat loss or more conductive for heat loss through it by changing the grading. You can't make it better, but you can make it worse. Everything else that's not part of the grading is done in accordance with ASHRAE Handbook Fundamentals. So you definitely want to have a copy of this ANSI standard ResNet, ANSI ResNet ICC 301-2019 if you're going to be using this so you can share this with your permitting official so they have that confidence that this is being done. Now, with all that being said, one of the big questions we get asked is, will I get the same answer if I build the same wall in a bunch of different tools? The answer is kind of. I took one with an R23 cavity. I used R2.5 continuous insulation, 16 inches on center, and intermediate framing. If you look at the building science advisor on the left, I got a U value of 0.049. If you looked at the ABTG, I got a 0.048. And if you look at REMRate, I got a 0.047. How is that possible? Well, remember that the REMRate tool allows for a parallel path with the stud, the cavity, and the header. You may remember that I mentioned these other two didn't have the ability to do header. They only had to deal with the dimensional lumber, is it 2x4, 2x6, or 2x8, and its spacing between them. So when you look at different tools like this, that's some of that nuance. They also maybe have different thicknesses of some things like the OSB. Is everyone using, the same OSB thickness, the same drywall thickness in their assumptions? So you really do want to check these out because you can get slightly different answers from 0.047 to 0.049 for basically the same wall. Again, the REMRate one is more nuanced. It allows for more data points of entry, but it's also really easy to mess this one up because you can adjust the framing fractions yourself, which I don't recommend doing if you're doing this for code, but you could do that. And so people can, I don't want to say cheat, people can accidentally even enter in the wrong piece of information and get a very different number. But REMRate is infinitely more flexible than these other two tools, but these other two tools, again, are giving pretty similar answers. And the answer could be 0.0484. And in one that rounded down, the other one, it turned out to be 0.0485, and it got rounded up. So how close they are, the answer is pretty darn close, but it is a little bit of nuance. In my opinion, find the tool that works the best for you, that you have the most confidence in, and then make sure that where you're working, those authorities having jurisdiction are going to accept the tool that you're choosing to use. Now, there are other tools out there on the marketplace. Again, we had a limited amount of time today, so I didn't want to overdo it on how many tools I reviewed. So take a look at the same basic guidance. Are the tools that you're looking to use referencing ASHRAE, either 90.1 or ASHRAE Handbook of Fundamentals? And are you using the correct default coefficients and the correct framing factors in the assumptions that you're putting in? And those are, again, going to be found in the IECC or in your state energy code appendices. They will tell you what you should have for those. Phew, that was a lot. I was worried we wouldn't get through all of this, but we are getting close to the end. So I'm definitely going to pause on this screen for a few minutes because this might be the best place for you to get some quick information. If you've got questions on the code compliance calculator in Washington or the C3 tool, I often email energycode@energy.wsu.edu and roosc@energy.wsu.edu at the same time. One goes to their general inbox in case Carolyn has the day off, and the other one goes to Carolyn's inbox. But this is a great way to make sure you're getting your questions about the C3 answered. Alternatively, you can call the code hotline there that you see and leave a voicemail if you don't get through. And that's a great way to make sure that you can get your questions on what the C3 is capable of doing answered. You can spend hours upon hours and just scratch the surface of what that tool can do. I didn't even mention the C3 calculator will automatically calculate your necessary ventilation rate for Washington State. And it allows you to put in some inputs on the design, whether it's balanced, supply only, exhaust only, is it distributed, and will actually tell you how much ventilation rate you need. It also has a code-based block load heat load calculator built into it. So on the C3, you can do an awful lot with that. You can show UA Tradeoff compliance, you can show compliance with your energy credits, you can show your ventilation compliance, and you can show your compliance with your heat load calculations, all in one tool. On the other side here, we've got I call it the Measure 6 Thermal UA. That's not what they call it. That's what I'm calling it for now. Just so you remember, you can email bcd.info@dcbs.oregon.gov, or you can contact Mark Heiser, or do it at the same time, mark.r.heiser@dcbs.oregon.gov. Or you can call their info line at 503-378-4133. Again, you can get clarification from Mark, particularly along that line of, I don't like that it says this is for Measure 6 only, for display Measure 6 only. I've got a copy of an email from Mark saying you can still use this tool for overall UA trade-offs and for Measure 3. So I feel confident in it, but you can coordinate and work directly with Mark if you've got questions about that calculator. I have checked with both. Unfortunately, Washington will not accept the Oregon calculator, and Oregon will not accept the Washington calculator. Basically, there's black box things happening in the background. Nobody's showing all their cards necessarily, and there's been maybe previous history that there were some custom entries added in to each of these tools that were not necessarily proven to be using the ASHRAE math, etc. So one tool for each state. Sorry that you can't use them both for both. So that's basically what I had, and we've just got a couple minutes left. So let's open it back up and see what other questions have come in.
That sounds great. We did have one question come in. This person's just curious if there's a new version of ASHRAE Fundamentals available.
So yeah, ASHRAE, it's funny. They break it into 4 sections, if I remember correctly. And so they constantly are updating a section. And that is one of the interesting things, is that you'll notice that these codes don't say which version of ASHRAE Handbook of Fundamentals you need to reference. So that's because these different settings are constantly being updated. That said, the basic math hasn't changed. As it turns out, physics is still physics since 2005 in terms of the heat loss math through buildings. What changes a little bit more rapidly is ASHRAE 90.1, because that's more or less a program standard for compliance with codes. So ASHRAE 90.1 probably changes more often in terms of the fundamentals of what's happening, because it's associated with energy modeling as opposed to math and physics. That's a different way to think of it. 90.1 is energy modeling based. Handbook of Fundamentals is math and physics based. It's easy to see how we can improve energy modeling. As long as you're on this planet, in my lifetime, we're not going to see huge dramatic changes in physics and math. I also noticed there was another one. What about Ecotrope? Ecotrope does have a wall calculator as well. It's not as nuanced as RemRates in terms of the outward facing wall calculator, but you may be able to go into their libraries and add custom ones as well. I have not checked that out to make sure but they do reference ResNet standard 301, just like RemRate does. So if that is an option in there, then you would use that same cutout. There is another tool out there that a lot of people around the country use called ResCheck. And ResCheck is actually a tool designed for code compliance with envelopes. The problem is it's not set up to do any kind of parallel path analysis, really. It's a pretty basic set of pull downs that you can make minor alterations to. So you are not going to get jiggy with a fancy highfalutin wall with ResCheck. If you're just really kind of curious about an R, wall with or without continuous insulation versus, really good windows, yeah, ResCheck is another tool that might work for you as well, but certainly not if you've got a really interesting or really custom wall. So I'm going to just leave, those were our questions. I'm going to leave my contact information up here. Feel free to reach out. And we are literally down to a minute and counting. So if there are any last second questions, we're happy to address them. Otherwise, we're going to try and turn this around pretty quickly in terms of getting out to everyone who registered. So even if you've got a coworker, friend or someone else in the industry who registered but could not attend today, we will send it out to everyone who registered. If you are a HERS rater, a program verifier, or an energy consultant, and you want to share this and talk about it with your builders, I think it's a great option. Please feel free to share it. I will also say that if you work for Energy Trust of Oregon's EPS new construction offering, really getting good at these tools for Southwest Washington and Oregon can be a really nice help for you when you do early design assistance meetings. Talk about a really great way to talk about pros and cons. You can have the calculator pulled up. You can talk in advance with some of the different trades about what options might be available in terms of windows or different walls and insulation packages. And you can do in real time UA trade-off calculations during an early design assistance meeting. For those of you not working with the EPS program, you can think of that as a less fancy naming convention for a design charrette, right? So same idea. This is a great tool to use at those types of meetings. If you are an insulator, a framer, a sider, someone who, window installer, this might be a really good tool to get to learn for Oregon and Washington, because you may be able to help a builder find a best price point that still meets the requirements for our envelopes. So again, if you have any questions, you see my name and my contact information up on the screen. Please don't hesitate to reach out. I actually have a new phone number coming, so that's why my phone number is up there, but that will shortly be in my email reply. But in the meantime, please reach out to me through my email or on LinkedIn, and I'll be happy to chat with you. And with that, we are at time. And Diego, I don't see any new questions. Do you?
Nope, I'm not seeing any either, Dan.
In that case, I think we're going to wrap up. Spoke too soon. I just saw one pop up, and it just says thank you. So you are welcome. You're very welcome, everyone. Thank you so much for giving us an hour of your time. I hope this was helpful. I apologize for how fast we had to go, but again, we'll email out this PDF today, hopefully, to everyone who registered. So thank you very much.